I'm a real champion of careers in chemistry, and I'll explain that as we go. And I'm going to just click and get started. So first of all, everybody can see that okay, right?
Yes, we can see it.
All right. And so we'll start with a couple of sort of generic slides about what is careers in chemistry. It's Chem 195, and point out that graduate students also take the class as Chem 295. So if you take 195, you'll be sitting in a classroom with first-year graduate students and maybe some other graduate students as well. Yeah, the course description designed to give chemistry undergraduate students an in-depth appreciation of career opportunities with a degree in chemistry. And what we do is invite professional chemists, and some of these have very allied professions, to describe their work and provide insights into their careers. The course is graded pass, not pass. It's based on attendance and participation. I'm proud to say that I invented the course back in 1993, and I have taught it every year since 1993, except for, I think, the last 2 years because of COVID, it wasn't offered. And what I'm going to hope to do is give you careers in chemistry will give you a view into the future in a way. And if you're interested, there's an article we published in the Journal of Chemical Education in 2011 about sort of describing careers in chemistry and what its purpose is. So here's the DOI for that if you want to check that out. How do I go to the next slide? I expected to just click on that button.
You should be able to either use your arrow keys or just click on the screen with your mouse.
Oh yeah, there you go. That was easy. So, and again, I'm going to do this kind of quickly because this is really not why you're here to listen to this talk, but you are expected to attend all of the careers in chemistry lectures. This spring, there will be 9 of them, and they take place on Friday afternoons from 2:10 to 4 p.m. While you're there, you can't use a laptop or your phones. I don't want people messing around with those things in front of our invited speakers. And I ask people to give me the speaker their full attention. And in addition to that, I ask everybody taking the class to sit in on what we call small group meetings. And that's you and another 8 or 10, something like that, students who will sit in a room with the invited speaker and talk. And those take place on Friday mornings between 9 and noon. I have some of those between 9 and 10, some between 10 and 11, and some between 11 and noon, so that if you're have any opening on Friday mornings, you'll be able to attend one of those small group meetings. If, because of your schedule, you have no free times on Friday mornings, then you have to let me know that. I'll verify it, and then you'll be excused from attending the small group meetings. But you should attend a small group meeting if you can, because it's you sitting next to a professional in a way that you don't really get to do otherwise. This year, we have 8 visitors, and here they are. And I use this little symbol here to represent view into the future, and each one of these speakers will give you a different view into the future, and you can see where they are. For example, our first speaker is on the faculty at the University of Baltimore in the School of Justice. He has a degree in chemistry, and you can see how that led to his career when he gives his talk. Over in this column, you can see who the UC Davis faculty member who is the co-host, and the point of showing you that is that we have, analytical physical chemists, we have bioorganic, we have all kinds of people who suggested the people to invite, so that it's kind of a broad swath of people with different kinds of backgrounds. They're not all synthetic organic chemists, which is what the agenda would be if I were the only one suggesting visitors. And the other thing you'll notice, we have no R1 university faculty on the list, and we never do, and that's because you have full access to people like that already. Just walk down the hall and knock on somebody's door, and you can talk to an R1 faculty member about what their job is like and all of that. the idea here is for you to rub elbows with people who are out in the real world in a way that you probably don't have access to in other ways. So that's maybe the key thing about careers in chemistry is you get to sit next to somebody and talk to them about their career in a way that would be very hard to do otherwise. The other thing I should point out that these people all are excited to come, and we don't have a lot of money to spend on this course. So each one of these people pays their own bills, their airline ticket to get here, their hotel, all of that stuff they cover because they want to come and share their insights with you. So that's a pretty impressive statement for these people. And again, we've been doing that since 1993. And every year I ask people and they all say yes. I think I've only had 2 or 3 people had to turn me down because they didn't have the resources to spend. So that says these people want to do this and they want to have a chance to interact with you guys. So that's kind of a special thing. During the course class time from 2:10 to 4 p.m. on Fridays, each speaker gives one talk, but it's sort of broken into 3 parts. Part 1 is a what I do talk. Part 2 is a career talk where they talk about what they think are job opportunities in their setting for people like us. And part 3 is I asked them to talk about a project from start to finish. And they have a lot of flexibility, and you'll see they all handle this different ways, but that was the instructions I gave them when I invited them. So when I say careers in chemistry, the bottom line is, and I say this with 100% excitement, chemistry gives you an incredible options for careers. It's absolutely amazing what people with degrees in chemistry go off and do for careers. And I think this course will give you a little bit of an insight into that. That's pretty exciting. Now, the downside of that is you're standing here looking at options and you're saying, how do I understand which one of these is the right path for me to take? Because you'll have so many directions you can take your career in. And that's the cool part about chemistry. The tough part about chemistry is how do you do that? How do you sort out which is the right path for you to take? Well, from my perspective, careers in chemistry comes along and helps you aim at the target, help you understand what those options mean and what might be the right path for you. And once you have that insight, well, you can grab the bull by the horns and make it happen. So that's kind of why we set up careers in chemistry. We wanted people to see options, and we wanted to see then people, the attendees, to see how to sort of sort through some of that and begin to plan a career. So this is my little cartoon for careers can be a hard thing to visualize. You're standing at the beginning of an opportunity and you can't see down the path very far to know, well, how does this thing unfold? What does it mean to be working for the Department of Energy, for example? So each one of you is faced with that in a unique way because we're all unique people. And what do? Well, you do what people do. You step back and you talk to people. You talk to your friends, you talk to the faculty in the chemistry department, you talk to your parents, you talk to lots of people to try to gain insights into what career A versus career F means. You can try to sort that out. Then along comes careers in chemistry, and it helps you visualize. And the way I like to think about it is, as you go through careers in chemistry, you're going to find yourself standing on the shoulders of people with different careers and using that perspective to sort of look down the path and see what careers in chemistry has to offer for you. So it'll help you, again, this image here, visualize the future, see the future in ways that are impossible when you're just marching through life on your own. And then you'll be able to set off on the right path for you, and you'll be able to determine what that path is. So again, these are the careers in chemistry speakers, and you're hopping up on their shoulders to gain an insight into things that you would otherwise not have access to. It's kind of a cool thing about careers in chemistry. So why take careers in chemistry? Well, I've already answered that. It's going to give you perspective. By listening to these 8 speakers, you're going to see a bunch of career opportunities that maybe you even hadn't thought about. You know, all of these represent career possibilities, and you can sort of look at each and every one of those gain a view into the future, and in the end, find what you're going to say is my perfect job. I think that's kind of the goal for careers in chemistry. And there you go. Now, I'm going to pretend for the rest of the talk like I'm a careers in chemistry speaker. Since I run the course, I'm going to blur the lines and not really follow the 3-in-1 talks that I told you my guests are going to do. I'm going to just rattle off about what I think. And the first thing I want you to know is that I grew up as a farm boy in Iowa, Northwest Iowa, right about there in a little town called Primgar. And I would not trade that growing up for anything. It was an amazing view of who I am and what I do and how you be successful by watching all the farmers and the people working around me have careers. The downside is it provided me a very limited view of what's out there and what could be my path, because what I saw in any direction that I looked was pretty much the same. It didn't look, I couldn't see the future very, very well. So I have to then say, you'll find this to be true in your own lives. Family plays a big role. And Mark Kurth has been blessed with incredible parents. Mom and dad, my mom Esther and my dad Ron, raised 7 of us kids on the farm, sent us out into the world. What I would say is I have 6 siblings. Several of them make what I make 4 or 5 times what I make. It's incredible. I think I have one sibling that I probably make more money than. The others have been incredibly successful as civil engineers, biomedical engineers, bankers, businessmen. It's incredible what my siblings have done. And that traces back to 2 parents who knew how to launch kids out into the world. The other thing is I've been blessed with an incredible Mark and Lori Kurth family. Lori and I got married in 1973. Hey, you're doing some math there. I graduated from high school in 1971. Yes, Lori and I were both 19 when we got married. At the time in Iowa, that didn't raise any eyebrows. That was kind of normal. I look back and I think, holy cow, 19? I got married at 19? Yeah, I did. Jennifer came along in 1976, Dan in 1978, Tom in 1982, and Jeff in 1985. And what I could say is I've been blessed with an incredible family. My wife and my kids are all just an incredible resource to me, and I'm very, very proud of every one of them. Okay, so that's one thing is you all have families. Family can play an important role in how you see your path and how to unfold your path. And in addition to that, wow, I had amazing academic mentors. Let me introduce you to them. This is Marilyn Ewald. She was my high school chemistry and physics teacher. She handed me off from high school to Jim McMillan, who was my undergraduate research mentor at the University of Northern Iowa. Jim handed me off to Tom Hoy, who was my PhD mentor at the University of Minnesota. Tom handed me off to my postdoc advisor, Wolfgang Oppolzer, at the University of Geneva in Switzerland. And this path led me to UC Davis. And what I want to do kind of for the rest of the talk is help you understand how did I develop a view of the future, having grown up on a farm in Iowa. Okay, so that's the plan. What I can say is one overriding thing that family and mentors taught me is aim big. And this little cartoon is trying to point that out. You'll have options. And the path you can see is often the path that most people take. It's the obvious path. It's the easy path. It's the path that most people take. My upbringing and my mentors taught me to look in a different direction and see and create my own path, a harder path in some ways, but a path that opened the door for me in ways that I didn't understand until I marched down the pathways. So don't be afraid to aim big when you're thinking about your career options. Okay, so again, I grew up in Northwest Iowa. This is a NASA image of Northwest Iowa at night. Each one of these little dots is a town. here's my town, Primgar. And sure enough, you can see that dot, that's Primgar, Iowa. That's where I grew up. Now, if you grew up in Iowa, most people from Iowa would say, Iowa is God's country. It's an incredible place. If you've never been to Iowa, go visit Iowa. But I have to admit, it's a bit one-dimensional, and I've sort of pointed that out. It's farmland as far as you can see for hundreds of miles as far as you can see. So it's kind of a one-dimensional view of the world, but you learn a lot about work ethic, responsibility, and lots of other things that served me incredibly well during my career, having grown up in Northwest Iowa. Okay, so there you go. Now that's a picture of the United States from a NASA image at night. Some of you are sitting there saying, oh, I wonder where the heck Iowa is. Well, I'm going to point it out to you. Here's Iowa. A little dot right there is Primgar. That's where I grew up. Now, from that little spot, I found myself asking the question, Mark, who are you? You know, that's a question each one of us has to answer. I had to answer it as Mark. Okay, so that's the big picture. If you zoom in a little bit, okay, here's Sioux Falls, South Dakota. There's Sioux City, Iowa. Here's Waterloo, Cedar Falls, Waterloo. There's Primgar. Okay, so that's where I grew up. Now, if you zoom in a little bit further, there's a aerial view of Primgar. It's a town of about 700 people. I grew up on a farm 3 miles north, 3 miles east, and 3/4 of a mile north of Primgar. I grew up on the prairie of Iowa, surrounded by farmland. And again, I wouldn't trade it for anything, but I have to admit it gave me a very limited view of what's out there and what might wait for me as I, was thinking about the future. Trying to keep track, okay? So there you go. I grew up on a farm in Iowa. If you grew up on a farm in Iowa, your view of the future is pretty limited. And when you think about you're graduating from high school and you're thinking about where to go, what next, what's the path, you don't have much perspective. That's the bottom line. So I had to develop that perspective as things unfolded in real time. And again, just to remind you, that's the point of careers in chemistry, is to provide you with some perspective. And don't overlook that. That's an incredibly important part of things, is developing a perspective. I'm going to show you now how I developed my perspective. Okay, grew up on that farm out in Primgar, Iowa. Mrs. Ewald was my high school teacher. Primgar, when you ride into town, there's a sign that says, "Welcome to Primgar, the only Primgar in the world." And the reason they can say that is Primghar are the first letters of the first 8 families to settle that when it was open country. And if you could read it, you can see the names of the people down below their first letter, and they put it together and came up with the word Primgar. Mrs. Ewald confronted me with the question, Mark, who are you? And in a way that made a huge difference in my life. And she developed in me a passion for science. I loved science, and I can trace that right back to Mrs. Ewald. She was an incredible high school teacher. So much so that when I decided to head off to college, I wanted to become Mrs. Ewald. My goal was to become a high school science teacher, coach the football and basketball teams, and live in Iowa. Mrs. Ewald basically said, believe in yourself and be you. Thank you, Mrs. Ewald. Now, it turns out that I can make the point. Can you see this okay? It's not hidden? It's okay?
Yes, we can see it.
Okay. The point there is that there were 39 in my graduating class. This is us taking our senior photo on the jungle gym at the playground. And there's me. I was the class president, so I got to take the seat of position, the honored position. And the point is that Mark Kurth and Jerry Smith both got PhDs in chemistry. Now you think about that, grow up on a farm in Iowa, 2 out of 39 got PhDs in chemistry. Thank you, Mrs. Ewald. She was an incredible high school teacher. And I can't tell you enough how many times she really helped me launch my career. So again, thank you, Mrs. Ewald. Okay, so what happened? I grew up on that farm, graduated from high school, and went off to college at the University of Northern Iowa in Cedar Falls, Waterloo, this town. It's about a 200-mile drive to that little Iowa town of Cedar Falls, Waterloo. And I joined the students at University of Northern Iowa. Now I'm going to say something that's kind of embarrassing. At the end of my first year, I had a GPA of 2.24. And I can tell you that's not because I was a partier. It's just that I didn't really know how to study. In high school, all I had to do was show up and everything was fine. All of a sudden in college, I was competing with kids in a way I didn't fully understand. At the end of the year, my GPA was 2.24. Now, it turns out I didn't care because I wasn't in academic trouble or anything. Everything was fine, I thought. Well, I signed up at the end of my freshman year. I signed up for sophomore organic chemistry. When I did that, I signed up for a class being taught by Jim McMillan at the University of Northern Iowa. After about a week of organic chemistry, I went to his office to introduce myself, and we started chatting. And at some point he said, well, Mark, tell me a little bit about your academic performance. And I said, well, I have a GPA of 2.24. And I didn't say that in an embarrassed way. I said it because it was what it was. And Jim looked at me like, oh my gosh. And he asked me some questions. He says, do you know that GPA matters? And I didn't quite know how to answer that. He asked, are you okay being average? Which is what a 2.24 sort of says about you. He said, would you like to have some options as you unfold things? And I'm sort of thinking in real time, where's this going? And he provided the answer. He said, if you think it matters, if you don't like being average, if you want options, then get to work. Raise your GPA. He basically was saying, Mark, who are you? In a way that I needed. And I want to just now fast forward by saying, had I not had that conversation with Jim, had I played this kind of GPA forward one more year, I would have never gotten into graduate school because my GPA would have been too low. Jim, thank you. Now, it turns out I'm in contact with Jim every month. He's retired up in the Seattle area. He's been an incredible person in my life, and I can't thank him enough for everything he provided. Look forward, my sophomore year, I had a GPA of 3.353, which raised that 2.24 to a 2.88. My junior year, my GPA was 3.76, which raised it to 3.18. My senior year, I had a 4.0 GPA, which raised it to a 3.38, which allowed me to apply for and compete to get into graduate schools. Had I not made that adjustment when I made it, I wouldn't have that GPA and I wouldn't be here talking to you about careers in chemistry. So I can't tell you how much I thank Jim all the time. Every time I see him, I remind him of this story and he just says, yeah, I was that good. He was that good. Anyway, so there you go. Turns out I did undergraduate research with Jim. This is the chemistry we were making from cyclohexenone dienes, and you could make the cross-conjugated or the conjugated, do a Diels-Alder reaction, do a retro-Diels-Alder, and make a benzene ring. And I could tell whether I had this diene, the cross-conjugated diene, or the conjugated diene by which aromatic compound I made. That was what I was studying. Jim, like Marilyn Ewald, said, believe in yourself. And he said, be you. Now, neither one of them said those words, but their actions and what they expected from me is what made this statement come to life. So after doing undergraduate research with Jim, I applied to grad schools. Why? Because all of a sudden, instead of wanting to be a high school chemistry teacher, I wanted to have Jim McMillan's job at a primarily undergraduate university. So I said to Jim, what do I need to have your job? And he said, well, you have to get a PhD in chemistry. So I had to go to grad school. So I applied to grad school so that I could become Jim McMillan. So you can see how my perspective is growing as I'm marching down this path. Okay, so I'm now thinking I want to go to grad school so I can find a job like Jim's. So what did I do? I applied to a bunch of grad schools and I decided to accept the University of Minnesota in Minneapolis, and I went to grad school in Minneapolis. Now you can see I'm sort of locked into the Midwest. Well, that's because it's God's country. Why would you leave God's country, right? And I went off to graduate school at the University of Minnesota. There I joined Professor Tom Hoy's group. Now it turns out Tom joined the faculty at the University of Minnesota the same time I joined as a grad student. In other words, I was his first graduate student. Tom, in a very unique way, also asked, as I unfolded things, Mark, who are you? And again, I want to thank Tom for doing that. And what Tom showed me really was that I was overwhelmed by the thrill of discovery. I loved doing research and discovering things. And I decided I wanted a research as a career. What does that mean? I wanted Tom Hoy's job all of a sudden. So I went from thinking I wanted to be a high school teacher to thinking I wanted to be a faculty member at a primarily undergraduate university, to saying, no, I want to be a faculty member at an R1 university. Okay, so now if you click forward a little bit, this goes back a couple of years, but a couple years back, I looked up Tom and he had 252 publications. As a graduate student, 8 of them were my papers. Here are the 8 papers I had. I did natural product total synthesis. I made aplecystatin, the first human being ever to make aplecystatin, published that in JACS. I'm proud to say that Tom's been on the faculty at Minnesota for 47 years, and only 3 graduate students have more publications with Tom than I do. He's had lots of graduate students and lots of postdocs. Only 3 are one better than me. That's because he taught me how to push the go button and to run forward. What did Tom do? He taught me, believe in yourself, be you. I want his job. How do I get that? Looked to me like you had to have a postdoc. So I thought, okay, I'm going to go find a postdoc so that I can become Professor Hoy. So that's the evolution. And now I'm thinking postdocs. So I have to remind you where we come from. In 1971, I wanted to be a high school teacher. In 1979, the start of my 4th year of graduate school, I wanted to be an R1 university professor. What does R1 mean? It means top tier research university. My view of the job that I've had is 85% of my job is research. Maybe 10% of my job is teaching and 5% of my job is service. I love this job. I hate service. Okay, not all service, but a lot of service is gibberish. Research just lights the way. I love research, and I wanted a job where I could do research. That was my evolution from high school graduation in 71 to the start of my 4th year of graduate school in 79. Okay, so what did I do? I decided, Mark, you've been living your entire life in the Midwest. Why don't you get out and see the world a bit? Talk to Lori. At that time, we had 2 children. Jennifer and Dan, and I said, what do you think? Let's apply to postdocs in Europe. That way we're going to go see the world. So in August of 1979, the beginning of my 4th year of grad school, I sent a letter to Professor Oppolzer at the University of Geneva. Why him? I thought he was the best organic chemist in all of Europe. And if I'm going to go to Europe, I'm going to work for the best, is my view. So I sent him a letter. Now, this is before email. This is before Google. This is before anybody owned a laptop that I knew. What did that mean? I put a letter in the mail, sent it. 6 or 7 weeks later, I got a letter back from Oppolzer offering me a postdoc. And I go like, yes, we're going to go live in Europe. And then out of kind of nowhere, it hit me that, well, wait a minute. If I'm living in Europe, how am I ever going to find a job in the United States? And again, this is before email. This is before any of this stuff. So I talked to Tom and I said, Tom, I think I want to accept this postdoc, but I don't want to come back and have to do another postdoc in the States just to find a job. And Tom said, Mark, apply for jobs now. And I said, what do you mean? He said, well, submit an application that's competitive and see if you can land a job. And if these people would allow you to go to Europe for a year before you come back and start the job. And I said, that's not possible. He said, no, if you compete, win the competition, they will hold a job for you for a year. So I said, okay, I'm going to do that. I applied to a bunch of universities, and I decided also to apply to a bunch of industrial jobs. After that process, by January of 1980, I had 3 academic offers: Syracuse University, University of Virginia, UC Davis, and had offers from DuPont and Dow. And I sorted that all out with Lori, and we decided to accept the UC Davis offer, R1 University. And so the point is that Marilyn handed me to Jim, Jim handed me to Tom, and that led to me getting an R1 job. Now I want to point out that, again, class of 71, if you're driving on Interstate 80 and you want to exit for UC Davis, it's exit 71. That felt like fate to me. I accepted the UC Davis offer, and that allowed me to, in August of 1980, at the end of my 4th year of graduate school, head off to Switzerland to join Oppolzer's lab. With Oppolzer, I did synthetic methods development. This is Wolfgang. This is the University of Lake Geneva with the big fountain. It's a beautiful place. He was a very impressive person. The main thing I learned from him is demand the best of yourself. Reach as far as you can. With him, he had, I can't read the number, but a number of publications, 2 of which belong with me. And what I did was developed chiral auxiliaries to do what ended up being an anti-selective Diels-Alder reactions to make chiral natural products. That's the work I did with Wolfgang Oppolzer in my 1 year at the University of Geneva. In September of 1981, a year after I started my postdoc, Lori and I packed up the 2 kids and moved to Davis, California. And I've lived in Davis since 1981. Malcolm Gladwell popularized the notion that it takes about 10,000 hours of practice to become an expert. Now, when I click the next click, you're going to find that, well, Mark Kurth apparently is a little slower than that. In 1972, when I was taking freshman chemistry, I maybe put about 6 hours a week into chemistry. When I talked to Jim, I doubled that up to 15 as a sophomore. Then I joined his lab and started doing undergrad research, and it probably went up to more like 30 hours a week doing chemistry for my last couple of years. Then I went to grad school, and my wife will attest that I probably worked about 70 hours a week doing chemistry. I cut that back a little bit in Switzerland so we could do some traveling and see Europe to maybe 60 hours a week. If you add all of that up, it took Mark Kurth about 21,000 hours to become an expert. So I guess I'm half as fast as most clever people. Instead of 10,000 hours, it took me 21,000. All of that sprang from this little town in Iowa where I didn't have any view that any of this could happen or was even possible. And because of this, the people that I was surrounding myself with, all of it unfolded. Okay, so this is now getting close to the end of my little presentation. My parents, followed by my high school teacher, followed by my wife, Lori, and our family, by Jim McMillan, my undergrad mentor, Tom Hoy, my PhD mentor, Wolfgang Oppolzer, my postdoc mentor, groomed me, this little farm boy, to become a synthetic organic chemist and to know how to spew out molecules like mad. Okay. At this point in my career, I have 352 publications, 27 postdocs have worked in my lab, 68 graduate students have worked with me, and 124 undergrads have done work. And again, sort of broadly stated as synthetic organic chemistry. And all of that happened in a way that I didn't even know was possible. But because of these people, it led to this, what I would say is a really fun career. Okay, so here's a quick overview of what my career, what it means. On the right-hand side of the screen, 50% of what my lab did was synthetic methods development. So for example, one of the things we did is we learned how to make polymer beads. Why? Well, we wanted to have beads that we could do chemistry on. And we took those beads and did what's known as one bead, one compound library synthesis to make libraries of compounds, very interesting, complicated compounds. And we can make thousands of compounds in, like, here's this 1, 2, 3, 4, 5, 6, 7, maybe 7 reactions. And you can run 7 reactions in a week. And if you do that, you can make tens of thousands of compounds in a week. We then use those compounds with collaborators to discover biologically active compounds. We also, a colleague of mine from American University of Beirut in Lebanon, he and I discovered what's now known as the Davis-Beirut reaction. Here's the Davis-Beirut reaction. In one step, it takes a pretty simple starting material and makes a very interesting compound. So what did we do? Well, about half of what we did was methods development. The other half of what we did was medicinal chemistry. And primarily we worked on cystic fibrosis and primary biliary cirrhosis, which are 2 diseases. My collaborator for CF is on the faculty at UC San Francisco. And my collaborator for primary biliary cirrhosis is in the medical school here at Davis. Interestingly, I've had funding from NIH and NSF to do this kind of work. And I think we had 25 years of funding. I'm not retired, so I don't have a lab anymore. 25 years of funding to do cystic fibrosis research and 25 years of NIH funding to do primary biliary cirrhosis work. So what did that mean? It meant that as a synthetic chemist, I made molecules that found a home in diseases, for example. Okay, so stepping back one step, I can say Primgar, Iowa was a great springboard for Mark Kurth. UC Davis was a great career setting for Mark Kurth. What does that mean? Better living through chemistry. And that started in 1972 and led to what I would say is a career I wouldn't change a thing about. I loved my career. So now what I'm going to do, you know what they say about advice? Advice is cheap. I'm going to throw you some advice. What is my advice? Okay, well, I'm going to set that advice up in a setting that I love. This is Boomerang Lake in Desolation Wilderness. You drive your car for about 1 hour and 45 minutes, park, hike about 2.5 hours up to this lake. It's got this nice little cliff, and you can jump from that cliff into the lake. Now, I've done that I've lived in Davis, I think now for 42 years, 43, something like that, 42 years. I've probably gone to this lake, I have gone at least once a year, sometimes 3 or 4 times a year, and swim in this lake. After we're done swimming, we complete the day by hiking to the top of that peak. So I've been to the top of that peak maybe 40 times in my life. That's Lake Boomerang. I love it. Now, I don't want any of you going there because I think of it as my own private lake. So I'm telling you about it. I'm telling you where it is, and I'm telling you don't go there because I don't want to go there and have to share the lake with you people. Boomerang Lake is my own little personal lake. All right, so now I'm going to give you some advice based on Boomerang Lake. This is my son, Jeff, my youngest. 2 years ago, he and I hiked up to Boomerang Lake and camped overnight a couple of nights. And this is my son, Jeff, about ready to jump into Boomerang Lake. And what I'm going to say next to it, this is me saying my advice, major in chemistry. Okay. Do undergrad research. That's what Jeff is pointing out as he's flying through the air. Do undergrad research. Walk on water with your chemistry. By the way, I took these pictures. I hope you're impressed by the fact that I caught that picture just like that. Walk on water with your chemistry. And then in the end, make a big splash with your career. That's my advice. Major in chemistry, do undergrad research, walk on water with your chemistry, and make a big splash with your career. Now you can shorten all of that to make it a little more pertinent to the moment, and that is launch things with careers in chemistry. That's my advice. Take careers in chemistry. It costs you a couple of hours a week. There are no exams. All you got to do is attend and participate, and it can change your view of everything. And I can't tell you how important that is. That's how my career unfolded, because my perspective grew as I went forward. I didn't get to take careers in chemistry. They didn't offer the course. I invented the course because I thought people needed to have these insights. That's what careers in chemistry can do for you. So I have to point out, careers in chemistry is not magic. Now, let me restate that. If you take careers in chemistry, you're going to gain a perspective you've never had before. It's going to become like magic. Then, to get your money's worth out of careers in chemistry, here's my advice. Attend. Actively participate. Don't just sit there like a lump on a log. Be somebody at those careers in chemistry classes. While you're being somebody, think. Think about who you are, where you're trying to go, what you can learn from this person. Take advantage of the moment. Ask questions. Finally, dream big. If you do those things, careers in chemistry can allow you to say, better living through chemistry. And I say it all the time. I have little plaques around my house that say better living through chemistry. Okay, so now I'm going to really, this is the last slide. Yes, there's a whole universe of career options. What's my advice? First, major in chemistry. Second, as a chemistry major at UC Davis, take careers in chemistry. Do undergraduate research. Get a PhD in chemistry. Do a postdoc in chemistry. Take an R1 university job. I'm telling you, I love my job. I would not change a thing about my job. The best advice I can give a young person is want my job. Get a job at an R1 university. Do research, and then enjoy a great life. There you go. That's my talk. Now, I'm not real sure how to exit. Is there any, how do I exit? Oh, stop share. Okay. Stop share. There you go.